Hello guys, in today's lecture we will show the reaction of Grignard reagent with alcohol as well as the Grignard reagent is reacted with a different functional groups, it having a acidic hydrogen. Okay, in this lecture we will see the reaction of alcohols. But in this reaction, firstly we can see the reaction which is happening by the cleavage of R O H bond, that is cleavage of ROH bond. That means the reaction it should be carried out, or the respective product is happening by the breaking of bond between oxygen and hydrogen atom. Okay, the Grignard reagent it is one of the type of cleavage of ROH reaction or the cleavage of OH bond. Okay, then another second reaction. First reaction in this point we considered as a Grignard reagent. Then second reaction we studied here. This second reaction is that the formation of ester. Okay, the ester is formed by the reaction of acid plus alcohol. Then it forms ester. Okay. If carboxylic acid is reacted with alcohol, then it forms ester. But in this ester, there are same numbers of carbon atoms are present, which is present in acid or it is also present in alcohol. In here, for example, this acid contains the 2 carbon atoms and this alcohol contains the 1 carbon atom. Then in ester there are total 3 carbons are present. Okay, that means when acid and alcohol is reacted with each other, then it forms the ester. Okay, then we take the example. We consider RC double bond OH plus HO R. This alkyl group indicated as a R dash. Okay. This reaction is carried out in presence of concentrated H2SO4. But as well as this reaction, it is a reversible reaction. This reaction is a reversible reaction. In this case, this concentrated H2SO4 act as a firstly, it acts as a protonating agent. And after that, this concentrated H2SO4 act as a dehydrating agent. Okay. In this reaction, concentrated H2SO4 act as a dual nature. Firstly, it act as a protonating agent. After that, it act as a dehydrating agent. Okay. Now, we goes towards this reaction. In this alcohol, the bond it should be break down in presence of oxygen, or bond it should be break down in between oxygen and a hydrogen atom. That means one water molecule it should be eliminated. We clear that, and it's a truth is the hydroxyl group is coming from the carboxylic acid and hydrogen atom is coming from the alcoholic molecule. The bond between this hydrogen is not eliminated. This hydrogen, that means the hydrogen which is present in carboxylic acid, which is not combined with hydroxyl group of alcohol, but it happens in reversible form. The hydrogen atom which is from the alcohol and hydroxyl group which is from carboxylic acid. Then carboxylic acid containing OH and this hydrogen, it should be eliminated, and there is a formation of ester. There is a C double bond O R dash plus H2, it should be eliminated. This is a reversible reaction. Then it forms a ester. Okay. Then in this ester, now how it is possible the hydrogen, how alcohol it donates the hydrogen, and how carboxylic acid it donates the hydroxyl group. Okay, but it is this evolution of water molecule, hydrogen from alcohol, hydroxyl group and carboxylic acid is a experimentally proved that by using a alcohol containing oxygen, by using a oxygen which is present in alcohol, by taking its a isotope. This is a isotope O18. In this case, the ROH group, this oxygen, it is a normal oxygen, but this oxygen, this normal oxygen is replaced by their isotope. The isotope of oxygen is a O18 isotope. That means if the carboxylic acid is reacted with, this is a oxygen, this oxygen is replaced by their isotope of oxygen, there is a O18, then this alkyl group is attached here, is reacted with concentrated H2SO4, Okay, then in this reaction the water molecule, it should be eliminated, and this isotope of oxygen, it combines with this carbonyl group, there is a formation of ester. After formation of ester, in this case the O18 is present in a ester. O18 isotope of oxygen which is present in a ester, it not present in a oxygen. That means the bond, it should be break down in between hydrogen and oxygen atom from in the alcohol. Okay, and this reaction is also reversible reaction. For better yield, this water molecule, it should be eliminated. For better yield of ester, this water molecule, it should be eliminated. After elimination of water molecule, the reaction, it does not show the reversible, but the water molecule is remains stay as it is here. Then this water molecule again combine with ester, and then this ester undergoes the hydrolysis. Then we also use the carboxylic acid as well as alcohol. Therefore, the most important point, the better yield for ester, this water molecule, it should be eliminated, or this molecule, it should be removed from this reaction. Okay. Then another example, this isotope of oxygen is replaced in carboxylic acid. That means the RC double bond O18, and this one is a H. This oxygen which is present in carboxylic acid, it is replaced by their isotope. The isotope of oxygen is a O18 plus alcohol is here. The bond, it should be break down in the hydroxyl group from the carbonyl carbon and hydrogen from oxygen atom. Then it is reacted with concentrated H2SO4. Then it forms a ester. That means RC double bond O. Here this alkyl group considered as a R dash. This one is also R dash. This alcohol considered also R dash. Then O R dash plus H2O18. Okay, H2O18. There is a formation of ester. Okay. From this reaction, the isotope of oxygen is going in water. Okay, that means the bond, it should be break down in between carbonyl carbon and oxygen atom. It is easily proved that by elimination of water molecule which contains the isotope of oxygen, that is O18. Okay. Then this water is also removed to avoid the reversible reaction, to maintain a better yield of ester. Okay. Then in this reaction there is a ester is formed. There is a ester is also formed, but this ester is formed by using concentrated H2SO4, concentrated and as well as concentrated H2SO4. The concentrated H2SO4 act as a dual nature. Firstly, it act as a protonating agent. After that, it is act as a dehydrating agent. Okay. This is a preparation method. First preparation method of ester from alcohol and by using carboxylic acid. Okay. This is one of the part of cleavage of OH bond between alcohol. Okay. Then we consider the another example. Okay. Okay, this is a acyl chloride. This one is a alcohol. Then this chlorine from the acyl chloride, it carries the lone pair, therefore it also acts as a base leaving group. And this hydrogen is present in acidic nature, therefore one hydrogen and Cl is also removed, and then it forms a ester. Then ROR, this alkyl group shows the R dash plus HCl is should be formed. Plus HCl should be formed. There is a formation of ester. This is one of the preparation method of ester from acyl chloride. This acyl chloride, it is one of the acid derivative. Okay, this acyl chloride is reacted with alcohol, then it forms the ester, and this HCl is formed. This HCl, it is present with ester, therefore this HCl again react with this ester, then it also gives the acyl chloride and alcohol. But to avoid the reverse reaction, this reaction is carried out by using a pyridine. The pyridine act as a base as well as it also useful for the neutralize the HCl, for the neutralize the HCl. By using this pyridine act as the strongest base. But this pyridine is useful to neutralize the HCl. After neutralization, we remains only one molecule, only one product, that is a ester. Okay, this is another method of preparation of ester. Okay, then we can also take the acid anhydride. This acid anhydride is reacted with alcohol. This alcohol contains the R dash. Okay, in this reaction, the pyridine is also used. The pyridine is also used because in this reaction the carboxylic acid is also formed. The carboxylic acid is also formed. In between this acidic anhydride or acid anhydride, this oxygen is a bridged oxygen, and this bridged oxygen is attached to the two carbonyl carbon atoms, and already we know well these carbonyl carbons are always electron deficient, therefore is nothing more electrons to donate the oxygen atom. Therefore this bond, it is a weakest bond, therefore it is break down with the hydrogen atom, therefore this bond it should be break down, and the bond between oxygen and hydrogen is also break down. Okay, then it forms the positive charge carbonyl carbon, and this is a negative charge. There is a formation of alkoxide ion. This alkoxide ion against attack on the carbonyl carbon, and there is a formation of RC double bond O R dash. There is a formation of ester, and by breaking of bond between carbon and oxygen atom, this breaking of bond we consider this bond, or this bond is also. Then this O minus is combined with H plus ion, and there is a formation of respect to carboxylic acid. Okay, this carboxylic acid again reacted with ester, and then it also shows the reversible reaction. To avoid this reversible reaction, we can use the pyridine. The pyridine also used as a base to neutralize. Here Cl is not here, therefore to neutralize the, or it is useful for neutralization of carboxylic acid. Neutralization of carboxylic acid. This is a preparation methods of ester. This is a preparation methods of ester. Okay. Please write down these notes. Okay. Then we again consider the first reaction, that is a preparation of ester. In that, when carboxylic acid is reacted with alcohol in presence of concentrated H2SO4, then it forms the ester RC double bond OOR plus plus H2 is formed. Okay. Then example of this reaction, as well as this reaction is also known as a esterification reaction. This reaction is also known as a esterification reaction. It is a preparation method of ester. Okay. Then we consider the example here. Acetic acid is reacted with ethanol in presence of concentrated H2SO4. In presence of concentrated H2SO4, in that concentrated H2SO4 act as a protonating agent, as well as it also act as a dehydrating agent. Therefore, the bond it should be break down in between carbon and oxygen atom, and also the bond is also break down in between oxygen and hydrogen atom. And there is the elimination of one water molecule. Then it forms CH3, C double bond O, O, C2H5 plus H2O. This reaction is also a reversible reaction. The name of this ester is a ethanoate. The name of this reaction is ethyl ethanoate. Okay. In this reaction, we can use the concentrated H2SO4. In this reaction, we use the concentrated H2SO4. Instead of this concentrated H2SO4, we also use a dry HCl. Also, we can use a dry HCl. This point is more important for JE as well as NEET as well as CET exams. In regular reaction, the carboxylic acid is reacted with alcohol in presence of concentrated acid. Then this concentrated acid, instead of this concentrated H2SO4, we can use a dry HCl. If in this reaction, that means when carboxylic acid is reacted with alcohol in presence of dry HCl, then it also forms the ester. Then by using this dry HCl, then this reaction is known as a Fischer sphere esterification reaction. This reaction is also known as a Fischer sphere esterification reaction. This is the name of this reaction. Then in this reaction, the dry HCl is used. If the dry HCl is used instead of concentrated H2SO4, then this reaction is also known as a Fischer sphere esterification reaction. Okay, this is the most important point. Okay, then in this reaction, one of the most important point is the preparation of ester and what is the role of alcohol in formation of ester. Okay, then if we can use the primary alcohol, then it also forms the ester. If we also use secondary alcohol, then we can also use the ester, but we can use a tertiary alcohol. Then ester is formed, but by using tertiary alcohol, the esterification process is more difficult than primary than secondary alcohol. That means we consider the reactivity of alcohol in esterification reaction. Okay. Then priority is a methyl alcohol is more reactive than primary alcohol is than secondary alcohol and then tertiary alcohol. This is a methanol is more reactive than primary alcohol, is more reactive than secondary alcohol, is more reactive than tertiary alcohol. Okay. Then reactivity of alcohol, which is totally depends on the how many numbers of alkyl groups attached to the carbon atom. If the number of carbon atoms goes on increases, if number of carbon atoms goes on increases in a alcohol, then the steric hindrance of bulky groups is formed. Steric hindrance of bulky groups is formed. Due to this steric hindrance, the decrease the rate of esterification reaction. That means if the number of alkyl groups, which is we consider in case of tertiary alcohol, there are 3 alkyl groups are present. In case of secondary alcohol, there are 2 alkyl groups are here. In case of primary alcohol, there are 1 alkyl group is present. And in case of methanol will show before primary, after primary, secondary, and tertiary alcohol. Okay, firstly we consider the tertiary alcohol. In this tertiary alcohol, there are 3 alkyl groups are here. Therefore, the steric hindrance of bulky groups is formed here. And by this steric hindrance, due to this bulky group, is present in an alcohol, then rate of esterification reaction it goes on decreases. That means if the rate of reaction it also goes on decreases, therefore it does not gives the bulky alcohol or bulky group of containing alcohol, it does not give the better yield of ester. Okay, then this is the most important point for competitive exam. This is the reactivity of alcohol in esterification reaction. This is a methanol is more reactive than primary alcohol, than secondary alcohol, as well as than tertiary alcohol. Okay, as well as by using carboxylic acid, the product of esterification reaction is also depends on the order of carboxylic acid. It depends on the order of carboxylic acid. Okay. Also depends on the alcohol, and also it depends on the reactivity of carboxylic acid. This reactivity of carboxylic acid we can see here. This is a reactivity order of carboxylic acid. Okay, the reactivity of order of carboxylic acid, it is in this, the more reactive carboxylic acid, it is a formic acid, then CH3CH, then CH3COH, this is the acetic acid, then CH3COOH, then CH3 CH3 COH, then CH3 CH3 then COOH. Okay, the more reactive carboxylic acid is a formic acid. Okay, in this case there is a isopropyl group is attached here, then neo group is also attached here, neo group is also attached here, there is a iso group is attached here. This is a acetic acid, this is a formic acid. The reactivity of formic acid is more than acetic acid, than this acid, because which it totally depends on the how many numbers of alkyl groups are present in acid. In this case there are 3 alkyl groups are here, therefore bulky group is formed, or steric hindrance of bulky group is also shown. Then this, if the steric hindrance or bulky group is also present in a carboxylic acid, then the reactive rate of esterification reaction also goes on decreases. Therefore, we can easily prepare the ester from the formic acid. Okay, this is the reactivity order of carboxylic acid, as well as we also studied the reactivity of alcohol. This is the preparation methods of ester. In that, if the carboxylic acid is reacted with alcohol in presence of concentrated H2SO4, then there is a normal esterification reaction, it should be formed. But when carboxylic acid is reacted with alcohol, this reaction is carried out by using dry HCl, then this reaction is also known as a Fischer special esterification reaction. Okay guys, this is a formation of ester. Okay, then after that, we also, one of the important reaction is that the reaction of alcohol with their metal hydride. That means reaction of alcohol with metal hydride. This reaction, the hydride means H minus, the metal we consider the M. This metal, it shows the oxidation state, +1 oxidation state, +2 oxidation state, it also shows the +3 oxidation state. Therefore, this metal commonly shows the positive charge species, and this hydride shows the negative charge species. This positive and negative charge species is combined with each other, then it forms the metal hydride. Okay, this metal hydride is reacted with alcohol. This metal hydride is reacted with alcohol. Then the directly we comes from the trick of this reaction, and after that they write this reaction. Okay, when metal hydride is reacted with alcohol, that means the metal hydride is reacted with alcohol, then H2 gas is evolved. H2 gas, it should be evolved. Okay, that means the hydrogen gas it should be eliminated, or it should be evolved. Okay, the hydrogen gas it should be evolved. That means the one hydrogen, that is the H minus coming from the metal hydride, and second H plus ion which is coming from the alcohol. That is because in this hydroxyl group hydrogen present in H plus form, and this hydrogen present in H minus form. H plus H minus is combined with each other, then it forms the H2, and after elimination of hydrogen there is a formation of alkoxide group. This is a alkoxide ion, and this alkoxide ion remaining combines with the electron deficient metal atom, and this alkoxide ion oxygen contains attacks on the metal, then it forms the metal containing alkoxide. Okay, now we goes towards the example. This reaction we consider here the methanol, that is a CH3OH. This methanol is reacted with sodium hydride. That means sodium hydride, it is one of the metallic hydride. Okay, or metal hydride. This metal hydride is reacted with alcohol, then H2 gas it should be eliminated. That means from this reaction the H2 is eliminated. The H from to formation of H2, the H minus coming from the sodium hydride and H plus coming from the alcohol. This H plus and this H minus combine with each other and then it forms the hydrogen. This hydrogen gas it should be eliminated, and after elimination of hydrogen gas there is a remaining, it is a methoxide ion. There is a methoxide ion and this one is a sodium. Okay, this oxygen attacks on the sodium, there is a formation of sodium methoxide. Then it forms the sodium methoxide. Okay, then next reaction we consider the C2H5OH is also reacted with sodium hydride. Then there is a formation of H2 gas. This H2 gas it should be eliminated, and the remaining part, that is a formation of ethoxide ion. This ethoxide ion is combines or attacks on the Na plus ion, and there is a formation of sodium ethoxide. Then it forms sodium ethoxide, and name of this reaction is name of this product is also sodium methoxide. Sodium methoxide. Okay. Then this reaction is one of the evidence to prove that the alcohol functional group contains the H plus ion, because this H plus ion is substituted by Na plus ion. From this reaction is also this H plus ion is also substituted by Na plus ion. That means this reaction is also evidence evidence which is useful for the determination of hydrogen is acidic in nature, which is present in alcohol. Okay, guys, this is some reactions. In this lecture, we study the preparation of ester. We study also the preparation of metal alkoxide ion. In case of ester, firstly we preparation of ester. In preparation of ester, we consider the carboxylic acid is reacted with alcohol. Secondly, we also consider the when acyl halide is reacted with alcohol. Third one is acid anhydride is reacted with alcohol. By using these three steps or by using these three reactions, we can prepare the ester. Okay. For better understanding, we write down the examples which is depends on the or which is a preparation of ester. Okay, guys, this is a preparation method of ester. It is one of the part of cleavage of OH bond. Okay, guys, thank you.